welcome to 2.19 melting. Here's a great picture. We've all seen something like this, I hope. The lava here from a volcano, very hot, very red, very dangerous, um, very beautiful as well. Quick review, we're talking today about melting. So we're talking about a change from solid to a liquid for that endothermic process. So it requires add to go from solid ice to liquid water. We have to heat normal rock, very hot, very solid, right? So then a volcano has to have a lot of heat, a lot of heat and pressure to melt rock and cause the flows that we see. Melting just occurs when the particles of a solid absorb enough energy to partly overcome the force of attraction holding them together. Very important that you read those words. What does this mean? Well, so again, we have these particle model of matter. We've got solids, liquids, gases. Solids are all these particles, very low kinetic energy. They're very stable. They're not around. Liquids, more kinetic energy, more heat, moving around more. And then gas has the so solid structure, shape is definite, volume is definite. Liquid, the volume is definite, but the shape is not. Glass or water in glass takes the shape of whatever glass. Or in the case of a lava flow, it just kind of goes downhill. Gas has no definite volume, it's going forever. Certainly has no shape as well. This is, you should remember that the melting point, right? Just like the freezing point, that temperature. Go back to our picture here. From a solid to a liquid, obviously is melting. From a liquid to a solid is freezing. That temperature is the same. So the freezing point and the melting point of water are the same, 0 degrees Celsius. Normally when we talk about freezing, we mean that we have to decrease that temperature from the room temperature, right? So water, we normally have to take away heat, we have to decrease the heat to freeze it. But then like iron is obviously a solid at room temperature, so we have to add heat. So we generally call it the melting point. But the temperature of the melting point and the freezing point is the same. All we're doing is we're adding or taking the heat to transition that substance from a solid to a liquid, and that is a physical change. So it's just, it looks different, right? Solid ice and liquid ice look different. Easily go back and forth. Physical property, just like color, or the hardness, or the density. So obviously, this lava is a liquid, water is a liquid, but physically, they're also different. So red water is clear, water is also very light compared to this dense there. And melting, of course, very important for making tools. And that's pretty much it. So just remember that the substance here can add heat, can make the particles move more, they'll spread apart. That point, at that temperature, we call the melting point. Metals, of course, have very high health, so it makes it very tough. Add a lot of heat, break them. Great little article here, great little video here. I recommend you guys all see about glaciers. On the left here, this is a big glacier, a block of ice. As the Earth is warming, climate change, blocks of ice are melting, right? Right, very small. This is having effects on the environment as well. Be sure to do the practice and answer some questions. Thanks.